So I've already kind of drawn the scenario for number 22 here just for the sake of time, but let's go ahead and read the problem. So at an accident scene on a level road, investigators measure a car's skid mark to be 88 meters long. The accident occurred on a rainy day and the coefficient of kinetic friction was estimated to be 0.42. Use these data to determine the speed of the car when the driver slammed on the brakes. And we'll answer that last part of why does the car's mass not matter a little bit later after some of the mathematics. Like I said, I've already drawn this scenario here. And since we're on a level surface on the force diagram, our normal force is equal to our force of gravity. And there's only a force of friction. There's not really an applied force here. So let's think about it a little bit. So let's go back in time to the previous chapter when we did this kind of thing. We said the sum of all the forces in the x direction equals ma, and this is kind of how we have to go about solving this problem. Because what we need to do is find the acceleration, and then it seems like we're going to be able to use a kinematic equation to find the velocity from there, and that'll be our answer. So the only force in the x direction looks like it's the force of friction, and it's a negative because when I see left I think negative. It's kind of following the convention there. Equals ma. And we know the force of friction is mu times Fn. So let's see, negative mu times, let me draw that a little bit lower, times Fn equals ma. And to simplify further, we know Fn equals Fg, which is mg, just our weight pretty much, so mg equals ma. And now we can cancel some things out. So let's see, negative mu, when we divide by mg, or we divide by m, just m, sorry, we divide by m, we cancel those out, and we're left with negative mu times g equaling a. So let's see, negative mu, I can plug in the values now actually. So negative, and let's say they told us what this was, negative 0.42 times, we know our constant gravity, 9.8 meters per second squared, equals our acceleration. So our acceleration, and I'm running out of room here, equals, let's see, negative 4.1 meters per second squared. And now I'm thinking we can use a kinematic equation, plug this in our distance, which is our x, and we'll be all set, and we'll have found our velocity. So I'm thinking we can use, let's see, v squared equals our v naught, or our v initial, squared, plus 2ax. Alright, so v squared, that's the one we're solving for. Our initial velocity is 0. You can call either one 0, really, just as long as you're consistent with that. Equals 2 times the acceleration we just found, which is negative 4.1, times our x, which we've known from the beginning, 88 meters. I'm just leaving the units out for now. So let's see, v squared equals negative 721.6. And then we take the square root of both sides, and we're left with our velocity equaling 27 meters per second. Fair enough. Hope that helps. I hope I gave some clarity on, or a review I should say, on doing this kind of method here, the sum of all the forces equaling ma, and our force diagrams, as we know, those always come in handy. So hope it helps.